Hello everyone, welcome all to Physics with H0X. So in this video we will discuss about some 2023 cpet physics paper. So let's begin. And here is the first question of the session, that is inversion temperature in Joule-Thomson effect in case of van der Waals gas H. And the options are 2A by RB, 2RAB, B by RB, A by RB, and here it has been mentioned that A and B are van der Waals constant. So here we know that the inversion temperature is 2A by RB, that is the option A is the correct answer. Then if a plane intercepts 2A, 3B, C in a simple cubic unit cell, then the Miller indices of the plane is, and the options you can see here. So it has been given that the plane intercepts are 2A, 3B, C. So we can consider it as the plane each intercept in the x-axis with 2A, in the y-axis with 3B, and in the z-axis in 3C. So we have to find out the Miller indices here. So here the Miller indices is HKL, and we know the process, that is, first of all we have to calculate the reciprocal of the intercept, and it will come out to be 1 by 2, 1 by 3 and 1, and then by taking the LCM and multiply it, we can find the HKL value H 3, 2 and 6. So the Miller indices here is 3 to 6, and here the option D is the correct answer. Then reciprocal lattice vectors of BCC structure are, and we all know that the reciprocal lattice vector of BCC structure is the lattice vector of FCC and vice versa. And also we have to know that the reciprocal lattice vector of SC is itself SC. So here the option D, that is 2 pi by A I plus j, 2 pi by A j plus k, and 2 pi by A k plus I is the lattice vector of FCC, and this is the reciprocal of BCC. So here option D is the correct answer. Then dispersion relation for linear vibration of one-dimensional monoatomic lattice is, and we all know that for monoatomic lattice the dispersion lattice the dispersion relation for linear vibration is W is equal to plus minus root over of 4 beta by m sine Ka by 2. So here option C is the correct answer. Then epsilon r minus 1 pi epsilon r plus 2 is equal to n alpha e by 3 epsilon naught is known as. For epsilon naught is the free space permittivity, epsilon r is the relative permittivity, and alpha e is the electronic polarizability. So we know that this is the Clausius-Mosotty relation. So here option B is the right answer. Then transition temperature, that is Tc, and critical field Hc for superconductors are related H. And the options you can see here, and the correct answer is Hc is equal to H naught 1 minus T by Tc square. And we have to know that here Hc is the critical field at temperature T, Tc is the critical temperature, and H naught is the magnetic field at temperature 0 Kelvin. So here option A is the right answer. Then interaction between neighboring dipoles is negligible in case of, and the options are diamagnetic material, antiferromagnetic material, paramagnetic material, and ferromagnetic material. So here the correct answer is paramagnetic material. In paramagnetic material, the interaction between neighboring dipoles is negligible. Then in chronic Penny model, the large scattering power of potential suggests for energy bands and electrons H. The options are allowed bands are narrower, allowed bands are wider, forbidden bands are narrower, and electrons are less blunt. And here the condition should be the potential barrier between wells are strong and energy bands are narrower. So here the option match is option A, which is the correct one. Then at non-zero temperature, Fermi-Dirac distribution is half when energy E is, and how the energy E is related to the Fermi energy EF. So here the options are E equal to 0, E is greater than EF, E is less than EF, and E equal to EF. And again it has been given that here EF is the Fermi energy. So you know the distribution for Fermi-Dirac distribution, that is F of E is equal to 1 by e to the power e minus EF by kt plus 1. And by putting the value of Fe is equal to 1 by 2 here, we can find the final result H. Here E should be equal to EF, that is the energy should be equal to the Fermi energy. So here the option D, which says E equal to EF, is the correct answer. Then choose the wrong statement for Bose-Einstein statistics. And we have to find out the wrong statement here. And the first option says it holds for indistinguishable particle. Yeah, we know that the Bose-Einstein statistics is holds for bosons, and bosons are indistinguishable particle. And then does not obey Pauli exclusion principle. Yes, because we can put any number of bosons in any energy level. There is no boundation that it should have any energy level should have one boson or two boson, so it doesn't obey Pauli exclusion principle. This is the correct statement. Then option C says f of e is equal to 1 by e to the power e minus ef by kt plus 1. And this is the wrong statement, because in the previous question we have seen that this is the correct form for the Fermi-Dirac statistics. So this is the wrong statement, and this is the right answer for this question. Then applies to phonon and photons. Yeah, this is the right statement. So here the option C is the wrong statement and the right answer for this question. I hope you all enjoyed the session. So for more videos, please do like, share and subscribe. Thank you.